Hi everyone, and welcome to our first wrap-up video for the week of Module 1, so the beginning of our course Question Reality. And the plan here is to very informally go over some of the questions you have raised and some of the good things that have happened and some of the things that we would like to see happening more often. And hopefully this will be a very useful guide for all the students to participate. Here on my right, I have one of your TAs. This is Michelle Stevens. She is a PhD student in physics here at Dartmouth. And she has been going through the discussions. You that have been posting may have seen her because she's been very active replying to many of you and your questions, right? Okay, so first of all, let me just say that we have many thousands of people in this course, and I apologize right ahead that we can't, of course, treat all of you individually. We would love to do that, but it's kind of impossible. But we're trying to do our best to kind of interact as much as we can with different people. And we have to say that we are incredibly impressed with the level of discussions so far. And let me just make one quick comment. Remember that about 35% of our students are from Brazil and they don't speak English. So if you give me one moment, let me just make a comment to them as well, because they need to know how to address this discussion in Portuguese. So, pessoal do Brasil, se vocês querem acompanhar essa discussão, que é basicamente uma revisão do que aconteceu durante a semana, você faz a mesma coisa que você faz quando você assiste os vídeos dos cursos, que é clicar naquela janelinha embaixo à direita em que você pode mudar de língua para português. Então essa discussão vai estar também traduzida com subtítulos em português, ok? Ótimo, muito obrigado. All right, so for the first week we had essentially three main topics, right? Yes. And the first one that I would like to mention is Plato's Cave. Right. So, Michelle, did you see anything interesting that people have done in Plato's Cave that kind of jumped out for you?
I saw a lot of analogies that were talking about climate change. That seemed to be a big topic of discussion. And some that talked about dreaming. I thought those were interesting.
So a dream state as sort of like similar to the fact that it's not really reality, but it feels like reality.
Yeah, while you're in the dream, you think, oh, this is my reality. And then when you wake up, it's almost this jarring sensation as you come to terms with your new reality.
Yeah. And of course, Plato's Cave is essential to us because it's just a big allegory to how we can be fooled by our senses, right? I mean, we may perceive reality in a certain way when the truth is elsewhere, right? And that's extremely important to remember. In particular, we talked about changing worldviews as well, right? And how that's very difficult to do. You get sort of attached to a way of thinking about reality, about the world, about your values. And then here comes science and threatens to demolish that whole worldview, and then you just don't know what to do with that anymore, and you feel lost and confused. And that is definitely true, And sometimes people's perceptions can feel very right to them, even though they need to be kind of broadened up. So there was a person from Brazil that came up with this really beautiful analogy, which I'd like to bring out, which he titled it 6 or 9. And the idea is that, if I make the number 6, right, on a piece of paper, and I see that number 6, if I look at it from the other side, it's going to look like a number 9. So the question then becomes, who is right? Looking from one side of the paper or turning the paper upside down and looking at the number 9. And the same person had the same analogy, which was really interesting, about if you ask people on the northern hemisphere, if you ask people on the western hemisphere if it's day or night, and ask the same question to people on the eastern hemisphere if it's day or night, they're going to say, oh, it's day. And the other guy is going to say, no, it's night. And they're both right, given their perspectives. So what do you do with that, right? I mean, you have to kind of explain to them that they're both right. However, they're not right or wrong. It's their perspective that is limited to their worldview.
I just think that's a great analogy. I wish I read Portuguese. But I think that's an interesting idea that, we have these two perspectives. Both might be right, but in order to determine which one, we have to ask for more information. We have to push a little bit further in our understanding.
And that's pretty much what science is about, right? I always say that science is the art of avoiding you to be fooled by your perceptions, So science is a device, is a way of thinking about the world that helps us go against this illusion that we may have that we know something when we actually don't know it, or we have certainty about something where we actually don't. So it's basically the art of not being fooled, right? Which brings me to the pendulum, right? So the pendulum, it was great. A lot of you did amazing things, right? I mean, Michelle may have some idea, some of the examples of people that worked on it that stand out. Do you have anything like that you can remember that was really interesting?
I think most people use the online pendulum simulator, but some people actually went out and built their own and hung it from fans in their living rooms and had really long pendulums, all sorts of different masses. So that was pretty cool to see.
So yeah, and so on that one, people might ask, why are we doing this, right? And I think it is really essential to do it, right? Even if you know the answer already. Well, most of you may not know the answer. Some of you were very surprised by some of the answers, right? But the whole point is precisely that you come into the experiment with a preconceived notion, right? For example, oh, if I increase the weight of the pendulum, it's going to oscillate faster or slower, right? I mean, the weight is going to have an impact on how this thing behaves. So that's your preconceived notion, right? And that is the being fooled by your view of how reality is. And then you do the experiment. You become the scientist, right? I mean, you're there and you're doing the experiment yourself. And then you realize that, wow, the way I thought about the world was wrong. Look at that. Reality is telling me something completely different and very much against my intuition. So that's why we thought it was kind of a fun thing to do and an easy thing to do in terms of let's have them test this reality. And I have to say, some of you did amazing things. And there was one fellow from Brazil, actually he's Brazilian, but he lives in Medford, Massachusetts. And he actually decided to go to a park, take his two nieces, right? So he took his two nieces to the park, and first he put one in a swing, let her go, calculated, the time it took for the swing to complete an oscillation, and then he put the other niece on her lap. So now he has changed the weight of the pendulum and did the same experiment, releasing from the same angle, and lo and behold, got the same result, right? And then, in order to change the length of the pendulum, he jumped up, swung the whole thing around so that he wound the chains, around the bar on top, did the same experiment again, and realized that the length of the pendulum, of course, affects the oscillation period, right? And if you guys did it really hardcore, you find out that it goes with the square root of the length, right? So that's actually the answer. So it's very cool that people use the online, right, to do this. But I have to say that how do you know the online is not tricking you, right? I mean, it's a simulation, it's a program. So somebody could have written a perverse program with the wrong answer. And you'd have done the experiment online, and you wouldn't know if that's right or wrong unless you got your hands dirty and you actually went to the park or hang something from the ceiling and did the experiment, right? So that's science in action, right? It's a way of going out into the world and trying to figure things in such a way that you do not get fooled by your prejudices. I think it was Einstein that said that common sense is the combination of all your wrong ideas until you are 18 about the world. And what we do is we just get rid of all of that as we move on into science.
So I thought it was interesting that some of you said, oh, I was really surprised by the outcome of this pendulum experiment, but then looked back and said, okay, I saw this Leaning Tower of Pisa experiment that Galileo did and found out that different bodies with different masses fall at the same rate under gravity, or the same acceleration. So now, knowing that the pendulum is put into motion by gravity, oh, well, I should have expected that. And connecting those two concepts together in different situations, I think, was really cool, and the power of science.
Yeah, no, that's excellent, actually, that they actually did that. It is essentially the same thing. A pendulum is a controlled free fall, if you want to think about it, right? And so, and some of you, said, well, but, there's air resistance, and because of air resistance, things are going to change a little bit, and that is all true, but that is not really the point. The point is that this is about science, physics, without the air resistance, right? And what happens in the absence of air. So that's why we had the link to the astronauts doing this experiment on the moon, because on the moon there is no air. So there you don't need to do like I did with the vacuum pump, and the big cylinder, the glass. You can just drop stuff, and it just doesn't matter if it's a hammer and a feather, they will come down exactly at the same moment. While obviously if you release a feather and a hammer here, the feather is just going to go real slow. But that's just because of air resistance. So is it true that the heavier thing falls? Well, it's not really the heaviness of it, it's the shape of it. So the way you calculate friction when something falls down has to do with the shape and how that, that shape makes things, fall faster or slower. So that's really it, right? But the point here is to think about the absence of air and how then the physics tells you something about all bodies falling together at the same acceleration, as Michelle was saying, right? And that is true not just here on Earth, it's true everywhere. So if you go to Jupiter or to Saturn or to another galaxy and you do the same experiment, the same result is going to be true. So it's a universal result. So gravity acts the same way everywhere in the universe. And that's super important, because if that weren't true, we couldn't do science, right? You couldn't be like, oh, can you imagine if gravity had different rules in different places? Science as we know it would be impossible. But what it does is that it opens up this whole new window in which even here on Earth, we can understand stuff about places very, very far away from here. So one thing that we wanted to mention to you guys is that this is only the first week of the course, and I have to say this is the easier week, right? As we move on to Module 2, things are going to get much heavier. In Module 2, we're going to go into the theory of relativity, both the general and the special theories. We're going to go into the expansion of the universe, into the concept of cosmic horizons, and the multiverse as well, right? And that's just week 2. So stay tuned, because if you thought this was a very introductory week, for some of you who are a little more advanced, things are going to get much more in-depth very soon. Also, a lot of questions that have been lingering questions are things that we are going to be addressing in the future. So for example, questions related to the nature of reality and consciousness, or computers and reality, simulations, all of these things are going to be addressed as we move on, right? So some people ask, can we know all of reality? So this is something we're going to address very soon in Module 2 with the concept of the island of knowledge. So another thing I wanted to mention to you, congratulations to all of you who started to add information to your learning journals. And I have to say that from my experience as a teacher here at Dartmouth, those learning journals are incredibly important, because they are a space for you to actually think critically about what you're learning in the course, put all your thoughts together, gather them there, and as the course evolves, you're going to have this beautiful summary of all the things that you have learned and how you have changed your ideas and your opinions, you know, how you have exchanged information with everybody else, right? I'm really excited to see that we have people from 140 countries in this course. So that means that you're going to be exchanging opinions with people from Norway, from Ghana, from United States, Brazil, Argentina. And this gives you a very unique chance to interact with people from all over the world. And this learning journal is a place where you can have your own commentary on what's going on. And it's a few years from now, you know, if you save that thing, you're going to have this amazing information about this course you took, and it's going to be a very useful resource for you. So now we're going to transition from Module 1 to Module 2, and in Module 2 what we're going to do is we're going to go into 20th century gravity. And that means studying the special and general theories of relativity and how Einstein applied them to the universe, and how this idea of cosmology, right, the study of the universe as a whole, changed during the 20th century from Einstein's first idea in 1917 to Hubble's and the expansion of the universe, and then all the way to modern ideas, including cutting-edge ones such as the multiverse, right? So that's the idea of Module 2. There's a lot of information that comes in here, lots of cutting-edge science, and I hope you will keep as active as you have been doing Module 1. It's been really exciting to see everything that is going on. We're all learning with you guys as well, you know, which is really what this is all about, and it's very wonderful. So I'll see you very soon. We're going to do these video wrap-up sessions every week, I hope. And don't forget, we also have the Ask Marcelo Anything on Reddit, and we're going to have a new session this Friday as well. Pessoal do Brasil, muito obrigado por tudo. Eu acho que nós todos estamos aprendendo juntos, e esse é só o começo da nossa aventura. São 6 semanas e a gente se vê já já. Até mais.